Alright, we're going to be starting Chapter 4, which is Etherchannel and HSRP. You'll have to excuse me, my voice is going a little bit tonight, so if I sound different, there's a reason. I don't know why it is, it just happened yesterday. I started losing my voice. It wasn't Super Bowl or anything, it was kind of just random. So, Etherchannel and HSRP, one a switching concept, one a routing concept. Okay, so here we go. Link aggregation, which is what Etherchannel is, link aggregation, and there's two different protocols for it. Why? Because of, well, allowing your traffic to have more bandwidth to travel over. You, in STP, are going to have a switch choose the best route based on factors we discussed last chapter to its destination, or which paths it should take, all of them being just, well, one cable or one line. All right, that's going to maybe give you a little bit of a bottleneck, especially if you have a 24 port switch. Even if this is a gigabit connection, if you've got 20 different users all on 100 megabit connections, you're going to be using more bandwidth than that one line is capable of carrying. With Etherchannel, you can turn multiple lines into one line of traffic. So that is what we're going to do with Etherchannel. So this Etherchannel, again, is going to give you more speed. Originally developed by Cisco to group ports into one logical channel. So for all intents and purposes, it's going to take multiple lines and combine them into one. In fact, you can see that it's going to take those physical interfaces here and turn them into a virtual interface called a port channel interface. Advantages, tasks are configured on the port channel, which is just one channel instead of multiple links, so you're only configuring tasks once. Uses existing switch ports rather than trying to find a switch or a expansion slot with more gigabit ports. You're just going to use the existing ports you have and group them together. Load balancing will occur between your channels. You're never going to have one channel faster than the other because you can only bundle channels with the same speed. So load balancing is going to occur and you won't have to worry about it. Okay, and Etherchannel does work with STP. So you can have multiple interfaces or multiple interfaces recognized as one channel. Our restrictions, one of which I just mentioned, is that you cannot have mixed speeds. If you're going to use a fast Ethernet port, which is 100 megabits per second, and a gigabit Ethernet port, you can't do that. They all have to be fast or all have to be gig. Can't mix the two. So that is a restriction that you have there. You can use up to 8 physical ports, either 8 fast Ethernet or 8 gigabit, and you can see the speeds that are achieved there. Cisco IOS only supports up to 6 ether channels themselves. That's not ports, it's the actual ether channel. So you might have, on a 24 port switch, 4 groups of 6 ports, which makes 6 ether channels, because you got, 6 groups of 4 ports, which would make 6 ether channels, because you got 6 groups there. So that's your limit. You can't really go above that. Ether channel group member port must be configuration. The ports that are in the ether channel must be configured consistently on both devices. So if you're a trunk on one end, you got to be a trunk on the other. If you're going to be an access port on one end, you got to be an access port on the other. Same VLANs across the trunk, same native VLAN is what you're looking for. Okay, hopefully my voice isn't sounding as annoying to you as it is to me. They don't have to be physically contiguous. You could use ports 1, 5, 11, and 14 if you want to. They don't have to all be in a row. That's fine. We also have two protocols, which are a port aggregation protocol, PAGP, and link aggregation protocol, control protocol, which is LACP. One of them is Cisco proprietary, which is the PAGP, that's Cisco proprietary, and LACP is not. So you'll probably find that you configure LACP a bit more than PAGP. Now you're going to have a table in your readings that'll show you how port aggregation protocol works. You basically have three different states: desirable, auto, on. Okay, and what happens when you have those? You know what? I'm just going to bring the chart onto the screen so you can see it. So if you have switch 1 and switch 2, you've got your on, desirable, not configured, so on and so forth. Okay, so how is an ether channel established? Well, if they're both on, then of course they're not negotiating when they're on, but since they're both on, then a channel is going to be established between the two devices. Okay, if you're on desirable on one end and auto on the other, or desirable and desirable, those are both negotiating states, you're going to get ether channel establishment, because auto's waiting to be told to form an ether channel, kind of like auto and dynamic in terms of trunking, if you remember. So auto's waiting to be told to become a channel, just like auto's waiting to be told to become a trunk. So it's the same type of concept there. All right. So only difference is, well, I won't get too far into that, but if you had two trunks, or a trunk and a desirable or a dynamic, then you'd get a trunk and trunking. The same's not true here, so I'm not even going to go any further with that because it's just going to get confusing. Anyway, two ons is on, a desirable and a desirable, or a desirable and an auto is on. Not configured in anything? No establishment. On and desirable, this is how it's different from trunk. That's what I was saying before. But this does not form a channel, even though you might think it would, because if you have this turned on, it's not negotiating. So even though this is indesirable, it's not getting told that S1 is willing to form a channel, basically. So it's just going to stay in this desirable state, not forming the channel, because there's no communication when either one of your devices is in the on state and the other device is in desirable or auto. So same thing down here. If you have on and auto, then nothing's going to form. Okay. So that's what we have there for PAGP. LACP, really the same type of thing. It's just instead of having desirable and auto, we have active and passive. So same exact type of chart, only we have active and passive rather than desirable and auto. Okay, so same situation, same concept, and that's how it's going to form. All right. Packets sent every 30 seconds, used to form a channel on non-Cisco switches. Remember, this is the non-proprietary version and the one you'll probably use most often, especially if you're in a medium-sized or small network. Many of those networks will not have Cisco devices because Cisco devices are really used more in large enterprise networks. So in fact, most of your non-proprietary Cisco protocols are the ones you'll use most often. So how do we configure Ether channel? We've got it coming up. Bundle interfaces must support Ether channel. Your duplex and speed must be the same. We talked about everything must match. Your VLANs must match. Your range of VLANs, if you're trunking, must match. So make sure everything's matching. as you set up your Ether channel, you shouldn't run into any problems. We'll take a look at how that's configured. Okay, so you're going to do your interface range. All right, and like we said, they don't have to be contiguous. They are in this situation. So you could go interface range 1 through 2, comma 3, comma this, comma that, if you wanted more ports involved in your Ether channel. Remember, limit of 8 ports. Limit of 8 ports. Whoops, went down a little too far. If you wanted to set your speed manually, you can. If you want to set your duplex to full manually, you can. It's just kind of recommended that you do not use automatic settings and just rely on them. If you set things yourself, you're sure that everything's set up the way you want it. Okay, so speed of 100. And you're going to do channel group some number, 1 typically if it's your first Ether channel, and then move on from there. Okay, so now you're setting up that channel by saying channel group 1, what mode is it in? We're using LACP, so we're in active rather than choosing desirable or auto. Okay, in LACP, it's active or passive. You've got interface port channel 1, which we just created using these commands. So now you're just treating it as a normal interface. You're going to interface port channel 1 just like you would go to interface fast Ethernet 1 or gigabit Ethernet 1. Okay, so we go there, switch it to a trunk, give it a native VLAN, allow some VLANs across it, turn it on with a no shutdown command, and that side is done on switch 1. You're going to do the exact same thing on switch 2, same exact commands. In fact, nothing at all has changed. Okay, once you've done that, no shutdown, Ether channel is going to be established, and that's it. That's all you have to do. It's not too bad. Okay, to verify and troubleshoot, you got show interfaces port channel, displays general status information. Show Ether channel summary is pretty nice. It shows you your group. Port channel 1, protocol, LACP, and it shows you the ports that are involved. Okay, so that's going to be some pretty useful information. In fact, I'm going to say, there's a reason that we use this graphic, because show Ether channel summary is probably what you're going to want to use, because it's going to show you all your Ether channels if you have more than one. It's not actually going to show you a certain number. And it does show you the ports involved in the protocol being used. So if you have labs in class, you need to verify your Ether channel, maybe troubleshoot. Show Ether channel summary should do you just fine. Okay. As far as troubleshooting goes, again, make sure everything's the same. We've talked about that a couple times. Duplex, speed, VLANs, native VLAN. Make sure it's all the same. Make sure that you've got the right negotiation options. If you're using PAGP, desirable and auto versus on, LACP, passive and active versus on, make sure those are set up correctly. You may want to shut down your port channel if you're making changes to it, because if STP is running, which it is if you're using the Ether channel, errors can occur with STP if you're making changes to an existing port channel. So if you shut it down, bring it back up, you can avoid some STP errors when you're making changes to your Ether channel, rather than trying to make them live without shutting down that channel. And really, that's it. You're going to be using, like I said, LACP most of the time, because that's the one that works on both Cisco and non-Cisco devices. So why would you use the one that only works with Cisco? We use LACP. Kind of like our preference is to use OSPF versus EIGRP. So first hop redundancy protocols for routers is going to give you the ability to have a backup default gateway. Because what if your default gateway goes down? you cannot reach other networks. Okay, there's no way to do it. There's no way to do it. So if you can't reach your own default gateway, even if there is another router, like you see in the graphic over here, your PC has a default gateway set and is trying to reach it. Okay, what we can do with this first hop redundancy protocol is create a virtual router out of two. Basically, what's going to happen is you're going to take two routers, and they're going to share the same virtual IP address. Okay, so two routers will both be under the same, in this situation, 192.0.2.100 IP address. All these PCs are going to see that IP address or be configured with that IP address as their default gateway. Even though the quote-unquote real IP address of those two routers is 192.0.2.1, 192.0.2.2. All right. How that's going to help is that as these routers configured with that virtual IP, you've got a active router and a standby router over here. Okay. As your PCs send traffic to this virtual IP address, it's going to go ahead, hit this router, and go on out to the destination. All right. This router over here is not doing anything, the standby router, but it is supposed to be receiving hello messages from the active router. If the standby router does not receive hello messages from the active router, it is going to go ahead and kick in as the active router. Packets that are sent to this virtual routing IP address will be sent to the standby router instead and routed through it rather than routed by this router that is down. Okay, so that's what you're going to get basically, is a backup router just in case one of your routers fails. The PCs will have no idea that it's happened. They're still sending to the same virtual IP address. It's just that virtual IP address could be occupied by the initial forwarding router or the standby router, depending on what's happened to your network. And you can see that down here. You would end up with the standby router sending out your traffic rather than that active router in case it died. So we have a list of our first hop redundancy protocols here. Obviously, you can see in the chapter title that we are going to be concentrating on HSRP, which is the Cisco proprietary first hop redundancy protocol. It provides redundancy for IPv4 hosts, and that's the one you are going to need to know for your CCNA. By definition, you should know the others, that ICMP Router Discovery Protocol, or IRDP legacy, first hop redundancy protocol, HSRP for v6, virtual router redundancy protocol, which excuse me, sorry, is the non-proprietary version of basically HSRP. As you see, a lot of the time we have the Cisco proprietary version or the non-proprietary version. You've got v3 of that, which supports IPv4 and v6 addresses and is more scalable than VRRP. Gateway load balancing protocol, Cisco proprietary, that provides load balancing between redundant routers. We don't get into configuring that. Gateway load balancing protocol for v6, you got that as well. So just know them by definition. The ones we're going to concentrate on are HSRP and HSRP for v6. Actually, we're not even doing for v6. We'll just do HSRP for v4. So here we have an overview of HSRP. Router select an active HSRP router that provides the default gateway services to hosts. We're going to talk about how the election process for selecting which router is active and which router is in standby in HSRP in just a second. If the active router fails, the standby router automatically assumes the active role. We talked about that before, without requiring any configuration changes on your host. All right, your versions, the default is version 1, but I believe we will set up version 2 in the example, which increases the number of supported groups. It changes your multicast address and adds MD5 authentication support, which you can see down here. Okay, so HSRP priority and preemption. Now, when we were looking at STP, spanning tree protocol, the lower numbers were what you wanted. Okay, and this is going to be a little confusing because in STP you want lower numbers. That's what gets you elected as the bridge, as the port bridge. Okay, here to become the active router, okay, you want the highest IP address or the highest priority. So it's kind of like backwards. So try not to get those two things mixed up. All right. So we have the highest IPv4 address. If you want to set the priority, you can make it the higher priority to be an active router. All right. The active router will retain the active role even if a router with a higher priority comes online after that first election is made. You'd have to force a new election if you wanted to, well, have a new election. And you do that using the standby preempt command on your interface. So that's the only way to force a new election after the initial election starts. So your HSRP states and timers, you've got your initial, which is something that happens when there's a configuration change, basically setting up the new HSRP. You've got learn, when your router has not learned the virtual IP address, has not sent any hello messages. It's waiting to hear from the active router. In listen, the router knows the virtual IP address, but the router is not active or standby. It just listens for hello messages when it's in the listen state. In the speak state, the router sends periodic hello messages and actively participates in the election of the active and or standby router. In standby, your router is a candidate to become the active router, also sending hello messages, and then, well, if you are elected to be active router, then you are in an active state, and you are going to forward packets that are sent to the virtual MAC address, and you're going to send periodic hello messages to the standby, or just in general, so the standby knows you're alive and it doesn't kick in on its own. Alrighty. And our configuration. If you want to use standby version 2, you can do that by using standby version 2. You're going to configure the virtual IP address by using standby, your group number, which is the number of your HSRP group, depending on the routers that are in it. Usually, of course, you start with 1, or you can use any convention you want, but typical to start with 1. Use your IP address command. If you want to set the priority, you've got the standby, whatever standby group number you've got there, then the priority number if you want to force an active router. The preempt again, the preempt command again is if there's already been an active router determined, but you want maybe this router you configured with a higher priority and you want to make sure it's the active router, you can use that preempt command to force a new election. Okay, whoops. Where did I go? There we go. Okay, and we're going to see that all in action here. So you go to your interface. Whoa, I'm really getting out of control there. So here we have the commands, interface, IP address. It's just using the short version, by the way. You can type out, the actual command is IP address. They just changed it to add because they couldn't fit in all these numbers, I believe, if they didn't. So you give that IP address to the interface. That's the normal IP address. Okay. Standby version 2 is going to take you to our HSRP version 2. You go standby 1, that's going to be your group number. IP, that's setting up the virtual IP address 172.16.10.1. Okay, that's what you would set up as the default gateway on your host devices. You're setting the priority there to a higher priority, and you're forcing the election for that group by doing your standby 1 preempt and a no shutdown to bring up the interface. Okay, we go over to router 2, same thing. Go to the interface, give it, I'm sorry, I can hear my voice getting raspier by the second. We give it an IP address, standby version 2, group 1, standby 1 IP, yada, yada, yada. Okay. Of course, this IP address is going to be the same, the standby IP, because this is the virtual IP address that both of those routers share, in which case, because if router 1 goes down, then this one's going to have the same IP address. These computers are still sending to the same IP address. It's just going to go through router 2 instead of router 1. Okay, so remember, this is the virtual IP. You go standby and then some number first. All right, that's basically all there is to it. And you can just verify it. Okay, you can do your show standby. We're on R1. You can see the virtual MAC that's been assigned, the virtual IP address. Active router is local, okay, letting you know that R1 is your active router. Okay. What else can we see? The standby router is the IP address of the standby router. If you do a show standby brief, you can see that you got your active router, your state for your current router, R1, active, it's local, standby again, IP address, virtual IP address. How that's going to look on the other router is this area here, up here, the show standby. You're going to see that that the virtual IP address is the same as we've got active router is at a certain IP address and it shows its priority. Okay, standby router is local on this one. And if you want to do show standby brief, you can see that the state is standby there. The active is here, the standby is local, we still got the virtual IP there. So that's what you'll see on both your routers when you issue those commands. We've got some HSRP failures and what they're related to. The election process, if you want to do the other election, or I should say reset the election, you've got that preempt command that you can try. Failure of the standby router to successfully keep track of the active router. Well, if it can't keep track of it, then it's going to try to activate. If it's trying to be the active router and the active router is still trying to be the active router itself, then you run into problems. Failure to determine that when the control of the virtual IP for the group should be handed over to another router, same type of thing. Okay. Failure of devices to be configured with the virtual IP. Some debug commands, you have those down there. Debug standby packets to view the exchange of hello. Use debug standby TRSC to view HSRP events if you need to. See if I have any graphics. You got your debug standby here, so you can see the time for hello in, time for hello out. And here is the other debug standby terse. You can see the process of a standby router changing into active as it the hello timer expires and it transitions over from standby to active in those steps. Okay. And then finally we have some other issues. Could be VLAN issues. IPv4 addresses may not be in the same subnet. You may not have set up the same virtual IPv4 address for your HSRP. Your group number's off. That's going to cause issues. And if your end devices are not configured correctly, that's going to cause you issues as well. So if you've got all those problems, you'll be setting up HSRP in your labs in class, most likely. So you can use those show commands and debug commands that we took a look at to dissect those issues if they were to come up. All right, so that's it. That's the end of that chapter. Thank goodness. I'm going to give my voice a rest. Hopefully come back stronger in chapter 5 with my voice fully recovered.